Hello, I'm Dr. John Cruz, and today I'm going to be talking about brain stimulation for ADHD. I hope you find it a stimulating topic. I will be talking for about 20 minutes, I believe, and I've gotten feedback that some of you just want the takeaway message in 1 minute and don't have to sit through the other 19, so I'll start with that. If you have questions, feel free to write them down and I will get to them at the end, and this will be posted both on Facebook and on YouTube under Dr. John Cruz, all one word. So the take-home, excuse me, take-home message is that trigeminal nerve stimulation, which I will be talking about in a completely separate session sometime in July, has shown some efficacy for children with ADHD, and two other modalities, which I'll be talking about today, TMS, which is transcranial magnetic stimulation, and tDCS, direct cranial, direct current cranial stimulation, have some suggestive findings, and there's almost certainly some potential benefits there, but not quite yet ready for prime time recommendations. And particularly, the studies to date would suggest impulsivity, consistency, responsive rate of response seem to be a little more responsive than attention per se or distractibility with these approaches. So that's the short take home. So jumping into, I'm going to give some background first on what is TMS or transmagnetic stimulation. So transmagnetic stimulation, TMS, uses a powerful pulsing magnetic field. It's a device put on your cranium, and that magnetic field causes changes in electrical signals within the brain. And depending on where that coil is positioned, and depends on which brain cells are affected by it, the frequency with which that pulsatile field is changing has, as far as we understand, impact on what kind of effect it has on the brain. So low frequency changes seem to have an effect on inhibiting firing in certain brain areas, in the brain area they're targeting, whereas high frequency pulsations of the magnetic field seem to elicit or boost firing in certain brain areas. So a coil is used to produce the magnetic field that's affected on the brain, and there's at least 5 or 6 companies marketing products in this country right now, mostly for treating depression. There's variability in the shape of the coils, and that may affect both the depth, how much they penetrate into the brain. It may also affect how broadly or focused the effects are. Certain other big factors affecting this in a clinical sense is how precisely the coil is targeted. So usually the starting points for measurements are using bony structures on the skull to help position the coil, and that's generally of some use. And then often they will stimulate the motor cortex, where the part of the brain that controls movement, and elicit a thumb jerk or another movement to make sure they have some fairly good idea of where they're placing the coil, and then move it proportionally from there. Those, though, are pretty crude measures, and there probably is a lot of variability from TMS location to clinic to TMS clinic, how skilled the individual practitioners are in finding the right area. In laboratory situations, there's increasingly use of either EEG measures or functional MRI to very precisely position and target the coils, but that's not yet the clinical standard. So TMS, for transcranial magnetic stimulation, was approved for treating depression, and specifically treatment-refractory depression that had not responded to at least 3 or more medication trials. So that was approved in 2008. Again, we've talked before that the FDA requirements for approving a device are much less rigorous, actually, than for approving a medication for widespread use. In depression, it's been particularly the left dorsolateral prefrontal cortex. So prefrontal means towards even more forward than frontal cortex. Dorsal surface is referring to the back, like a dorsal fin on a shark. Ventral surface is our underside of our body, where our vents for venting urine and other substances. So ventral is the underside, dorsal is the backside, prelateral or prefrontal cortex is so forward, and sort of both here and here, the frontal cortex is what we're targeting in depression. So with ADHD, there have been a handful of studies going back to across the last decade. Most of these are really tiny studies, 10, 12 patients. There's been almost an equal number of studies which found no effect on ADHD, which found effects for ADHD. Again, placement of the coils is one factor. Again, the specific coil and how deeply it's penetrating, the frequency of the signals that are being generated, how many treatments are being delivered. So it's not known whether the huge variability in terms of no response and some substantial responses, which factors may be responsible. So I'm going to mention that one of the more recent studies published in 2020 by an Israeli group, and they looked at 43 adults. It's the biggest study I've seen. There may be more out there. And it was specifically targeting the right prefrontal cortex, and that's where most of these studies have focused, because there's a pretty broad consensus that functional imaging, other studies in people with ADHD have suggested hypofunction, underfunctioning, underactivation of the right prefrontal cortex in ADHD. This Israeli study I'm talking about used 3 separate groups, so a treatment group using the coil to target that right prefrontal cortex, and 2 what were tried to be control groups. So one was targeting another area of the brain, not that right prefrontal cortex. That was the active control group, and a sham group where they had a coil and they turned the coil on, but it wasn't even directed, so it was penetrating the brain at all. And this group also used EEG markers to study what was going on in the brain during effective treatment. So they also used a variety of both ADHD scales. They used the Conners scale. They used one of Barkley's ADHD scales. They used, in addition to the scales, or self-assessment rating scales, they also did formal neuropsychological testing using the Stroop and some other tests to measure response time, looking at response inhibition, looking at short-term memory. So they were using both self-assessment approaches and measurable clinical variables. And they found that there was improvement. So they gave people treatments for 3 weeks, every day. It was less than an hour of treatment in this. I don't have the exact number right now. And at the end of those 3 weeks, there was improvement in a number of self-assessment attributes of ADHD, particularly in the hyperactivity, impulsivity domain, less pronounced in the attentional domain. And maybe more excitingly, that this group also found that in the alpha and gamma ranges of their EEG scanning, they could identify which patients were likely to respond. They could see changes in the EEG profile for a subset of patients that did respond. So jumping back to the response a little bit more, their assessment of the magnitude of the response was that it was roughly comparable to the size of the effect that people get from medication trials. That's a ballpark estimation. And the percentage of people actually responding was less robust than we get in most of our medication trials. It was only about 40% of the individuals who responded in the active treatment group. The control and sham groups were 10% or below. So again, a robust sort of placebo versus active treatment group response, but lower response than we usually see for medications for ADHD. And again, the useful thing here is that their EEG measure predicted who may respond. So after a single treatment or so, having a marker like this is incredibly useful. Again, particularly in a treatment where half the people didn't respond, if you can see on your EEG measure that there's an indication, a marker that's changed in some people, and that's a strong correlator predictor of response, you can tell the other half who aren't showing that change after treatment, this isn't likely to work, you can go home, we're not going to give you 3 weeks of treatment. The other finding from the study and some others is that looking at people a month after the treatment stopped, there was a decrease, not completely eradication, in the benefits that had been found. So there were some lingering effects, but they certainly shrank over time. And for many people, the goal is to find treatments that not just you need to use every day like we use medications every day, but that hopefully would have a permanent or longer lasting effect on the brain. So I didn't mention side effects. So in this group, there was actually one of the active control people had a seizure. So seizures are a rare but known possible effect in TMS studies. Usually most people in the TMS studies for depression, for other mental health conditions, usually considerably fewer side effects in our medication trials. So some people have headaches, some people may have ringing in the ears. The machines are loud. They're not as loud as an MRI machine doing brain imaging, but usually the protocols have people wearing earplugs during the treatment. So headaches, sometimes ringing in the ears. Some people do experience some discomfort on the scalp or irritation. That's not particularly common. Some people in the depression studies have been triggered into bouts of mania, also not particularly common, and not an occurrence in any of the ADHD studies that I'm aware of. So the summary for TMS is that there's a good body of evidence that this is successful treatment for depression in some people. And again, when applied to the right prefrontal cortex in a high frequency setting so that we are hopefully activating right prefrontal cortex, there are at least preliminary studies suggesting benefits for people with ADHD. So the other technique I'm going to talk a little bit about today is called direct transcranial nerve stimulation, or direct cranial stimulation. And this is a very different approach. It's still using something in the electromagnetic spectrum, but rather than a fairly powerful magnet, direct transcranial stimulation is using the little rectangular 9-volt batteries, usually, and delivering a current that's only 1 or 2 milliamps. So tiny amount of current, but applying those electrodes directly to the scalp. People have been experimenting with this for 50, 60 years, and part of the difficulty in studying it is that there isn't any, there's one company called AlphaStim that makes a unit you can buy for several $100s, but much of this is sort of home hobbyist research. So I had a patient 15 years ago who used the little 9-volt battery, used some electrodes he got from Radio Shack before they went bankrupt, used a little plastic toothpaste toothbrush holder to sort of hold his device together, and tiny little sponges as the parts of the electrode at the end of his wires, and made a device that he felt helped with his ADHD. So a lot of home hobbyists are involved in this. So again, this is using tiny sort of weak currents to either excite using an anodal current, again depending which electrode you're putting in contact with the brain and which is directing or a cathodal current is thought to decrease the neuronal firing in the area that's affected. Again, clearly placement of where you are targeting this may be important. There is weak evidence that this can help with depression, again, plagued mostly by the heterogeneity in different studies and different target areas. And the other really big area for home hobbyists has been in people who are ostensibly normal. You might question, how normal are they to be applying at home electrical currents to their head in terms of hoping that it will improve their functioning. But the other big area that's been a topic of research is in normal people without a mental health condition, whether they're able to enhance cognition with these treatments. And most of the targets of enhancement that they're going for, improved attention, decreased impulsivity, improved short-term memory, are areas of cognition that are impaired in many people with ADHD. Several of the meta-analyses trying to look at the studies would say that there's no compelling evidence, but that's because there have been a number of negative studies as well as a number of positive studies. Again, almost all the studies have been teeny tiny ones for just normal, again, enhancing cognitive function in normals. There's a much smaller field of studies, published studies, looking at direct cranial stimulation for ADHD, and almost all of these have targeted, again, the dorsolateral prefrontal cortex, and using anodal stimulation, which we think is exciting the brain, again, primarily on the right side, dorsolateral prefrontal cortex. There's a small handful of small studies showing improvement in some ADHD symptoms, again, more on the impulsivity, hyperactivity realm than the attentional realm. That can't be a conclusive finding with the number of studies so far. And there have been interesting studies, particularly people in Korea, people in Israel, people in America are studying this. I'd say the three leading areas. There's a small number of studies looking at rat models of ADHD and showing with direct transcranial stimulation that we are boosting dopamine neurotransmission in the same dorsolateral prefrontal cortex, and that we are showing general activation in frontal cortex from stimulating a fairly small discrete area. And so again, there is some weak evidence from our direct transcranial studies that this may be a tool in the future. I would not recommend going out and using your 9-volt battery and hooking it up to your own head at this stage. The effects on both dopamine neurotransmission in animals and other measures seem to suggest that, again, after several treatments, they could see effect, and that after stopping those treatments, there seemed to be some waning of effects. Again, the longer-term hope is to get some permanent benefits, but for some people, these may, in the future, be, even if you need to do them regularly, they may be alternatives to taking medications regularly. A word about the TMS, that right now, and this was actually 2 or 3 years ago, the summary I looked at suggested that the average cost at the TMS clinics, and again, they are mostly targeting depression, were charging above $300 for a less than an hour treatment. Most of them are recommending 5 days a week for 3 weeks starting out, so this can get pretty pricey. Medicare and other insurers are already covering TMS treatment, but there is often a sizable copay in addition. Out-of-pocket costs may still be considerable even if insurers wind up paying for this. One other, when I was listing side effects, jumping back to TMS, a possible or concern or contraindication is people who have a pacemaker or an insulin pump, other electronic device implanted in their bodies are not candidates for TMS because the pulsed powerful magnetic signal may cause electrical signals that disrupt that device. With the direct transcranial stimulation, again, side effects seem to be mild. There's some people who've had either irritation at the site of the electrodes, even mild electrical shocks or singed hair has been reported. Again, it's only a tiny 9-volt size battery in most studies. And also headaches in a small percentage of people. So I see one question. So next week I will be away on the early 4th of July holiday, so I hope you can enjoy it too. I see at least one question that I will answer or try to answer right now. So the person writing in Mark has gotten a Fisher-Wallace electrostimulator for light ADD and sleep. He wakes up after 6 hours when I need 8 hours and requires meds to stay drowsy and fall asleep. So he's had, it sounds like, minimal benefits so far on his transcranial electrical stimulation device, trying to use it for extending the hours of sleep. And any thoughts? So the Fisher-Wallace is one of the devices that's been around a long time. So there's also questions with some of the direct current devices. So again, unlike the pulsating magnetic current with the transcranial devices, they're using a continuous current, but there's also been debate about how important the waveform of the current is. So that's another added variable. And the huge one would be if it's not effective, does it mean if you change the target area a little more or could there be a place that would be more effective in extending sleep? I'm not aware of any rigorous studies looking at it for sleep, so I will, I guess, not comment more because I just don't know more right now. So sorry to be disappointing, and I'll try to look that one up. So that's all. I don't see any other questions coming in. And again, be healthy, be happy. 2 weeks from now, I'll be talking about the benefits of nature for ADHD. So that's nature, being outdoors and in the green. That's all for now. Bye.